Okay, so this is a Bridgeport. I got really close space here to work in, so I'm using the phone to film this. I don't know how it's going to come out, but we're going to give it a shot here. So that's obviously the side there, and I'll just come in close and start with the table. Okay, um, like I said, these are NSK LS 25mm rails, and the reason I went with these is because that's what was around at the time, and I had just found out that the mill was really shot. So I'll get into that at another point. So I believe, if I'm not mistaken, this is an NSK ball screw also. I believe that's 20mm. Okay, and I don't know what you'll see in there. Nothing. It's pretty dark. Okay. Now really, let me go back. I want to show you something. I was on some sites, and what they did really, the ideal way to mount these is to mill like a little channel for the one rail to sit in, kind of like a fence on your machine, or if you're grinding, you always have like a datum point, and then everything was worked off of that. So you knew that rail was straight, and then you could mount this one, and they called it a floating rail. But what I did, I checked it pretty close all the way down the whole length of the table. It's I want to say 49 inches if I remember correctly. And I got it like really close. So far, I haven't had any issues. This bearing block, I just made that out of some aluminum I had laying around. And the saddle, that's 1 3/4, 60/61 by 8 inches wide, and I believe 49 long. And that came from Hadco. So I'll just lift this up. I don't know if you'll be able to see under there. Okay, there's one rail that's sitting right on the knee, and you know what I did? You'll see it's on a block. That's a piece of tool steel. I think it was 5/8 by 1 3/4 by whatever the knee was in length. I forget what it was. But I did that because of, you can see where the way is, the V, or the dovetail rather. There wouldn't be room to mount the guide rail, the linear rail, right down to the knee, or the way rather. So that's the way I did that. Come around to the back, you can see more, probably in better light, I hope. Yeah. So, oh, I see we got some rust going on there. And I wasn't sure if I was going to put a side plate on or anything to help keep pressure on it, but it's screwed down with, I believe I used 3/8/16 bolts right into the way. And when you do this, you got to be careful, because underneath there's like a web in the casting. So if you can kind of lay out your hole so you don't hit a web. I got lucky and I just grazed one or two, and it worked out okay. So in here you can see the ball screw. That is a direct replacement for a Bridgeport. I believe it's 1 1/4, and I don't remember the pitch on it, but I want to say that's NSK also, but I could be mistaken. So here's a shot from the front. You can see the two rails mounted there, and way down in there in the dark is part of the yoke that's coming up from the piece I made that's housing the ball nut screw, or the screw's ball nut, and then it's mounted right to the saddle. So yeah, it's not focusing because there's not enough light, but we'll do something with that. So now underneath you can see there's 1, 2, 3, 4. Okay, I got 8 bearing blocks on the saddle, okay, and the other one's behind this. So there's 4 on this rail, 4 on the other rail. I'll go around to the back, see what we can see there. Looking down, okay, you can see the 4 blocks. Alright, so now the table was 2" by 8" by 49 aluminum, and all I did here really was mill out this pocket, and that was really just to give clearance to the ball screw. And then in the center I have a pocket milled out, right, you know, like right in the middle of the table underneath, and that houses the ball nut, and then that is screwed to the table. So that's how it's all tied together. So let me see if I'll get Mach 3 fired up, and we'll move this table down so maybe you can see a little more of what's going on in there. It's really not much to see, but we'll see how it goes. That wasn't good. And it would help if I plug in the motors. Alright, just real briefly, I use the ClearPath SK motors. They're really good so far. I can't complain about them. They set up really easy. And they're pretty powerful too. So let's see if I can't move this so we can see some more stuff. Okay, there's my other limit. I don't have limit switches on this. I just set them on through the Mach 3 software. So, you know, again, it's basically like the other side, and you got the other bearing block here. And, you know, obviously in here we got a pulley. I did like 1-to-1 ratios. It's because of what I had around. I think I could do that, or I think it was suggested a 3-to-1. So, you know, either way, you know, it was going to work out fine. And, you know, everything is housed in here. Just a little guard I made. So, that's pretty much what's going on there. And there's really not a whole lot to see. Maybe the still pictures will show you more. Oh, okay, you know what? I wanted to clarify something. I said that table, or rather the saddle, was sitting on 4 bearing blocks. I was wrong. I started out with 4, but then I found these huge guys here, and I decided to go with them because it covered almost the whole width of the table, and I just decided that was a better way to go. So anyway, that's what's going on there. Now, I forget what I set the maximum speed or feed rate for the motors. I think it was around 400 inches a minute, which is, you know, more than enough for me. But right now I have it set to, what did I go up to? 70%. Just give you an idea. Now, yeah, it'll go faster, but you know, I mean, like when you're doing little moves in a program, I know it's not good to be, you know, blasting super fast to the next position. It's just, you know, a lot of strain on the machine. So, all right, you know, I think you probably saw that it was a round ram. And I'll tell you why I bought this. The reason why I was looking for, basically because of the price. Okay, I knew they were cheaper than the conventional V-rams. But what's you know, these machines were great in the day, but you know, when you're milling and you know it just starts to dig in a little bit and you feel a grab, you know that's the machine telling you, okay, you knocked the head out, so now you're going to spend 20 minutes or whatever squaring up the head, because these were a pain in the neck to get trammed in. So I thought I'd just show you a couple things about this. Has nothing to do with the linear rails, but this, and I didn't even notice this until I got it home. If you notice, there's no nod on this head. It'll go from left to right, but it won't nod forward and back. A little transition period Bridgeport went through before, you know, they went to the V-ram style. So anyway, I just want to show you what I did to help keep the head in place. And you know, after hearing about me drilling into the ways and tapping, and I guess I can't shock you much more than to show you what I did on the ram itself. So what I did to help to keep it in place, I don't know if I'm too close to this. Alright, so you can see it's a split clamp. Okay, so it's bolted to the casting here and here, and then on the bottom there's two bolts, okay, and then a bolt on each side. And now you might think, well, clamping it isn't going to do much, and you're right, it's not. So I sent another bolt right through, right into the ram, one on the top and another one on the bottom. And you know, I figured, well, you know, I'm not going to try and switch it over to a V-ram, and I don't plan on pulling this in and out, moving it all around. So I figured, let me try this, and so far it's working pretty good. And if you're wondering, the ram really isn't bad to drill and tap. It's, you know, I don't know, I've talked to some people, and when I told them it was cast, they kind of cringed, as if it's going to be a big issue, but it really wasn't. I didn't have a problem with it. And I have done some you know, not hogging, like I didn't bury a 3-inch shell mill into a part, obviously, with a, you know, 1-horse motor, but for a 1-horse machine, I really can't complain. And yes, that is a cheap Chinese vise. It's not bad if you don't mind spending about 20 minutes deburring it after you get it out of the box. And something I'd point out, I don't even know which make it is. It's probably just got a number on the facility, you know, on the casting somewhere for what facility it came out of. But this surface and this surface is not the same by any means. I mean, there's like a this is higher. There's like a country mile. You can even see just the way the jaw sits here versus on the live jaw. But you know, I needed a vise because I had a guy loan me, and then I'm tightening it and I realized, this thing is cracked. And I talked to the guy, said, oh yeah, I forgot about, that one's busted. So anyway, I just picked this up, and it's not bad for what it is. So anyway, well, I hope you enjoyed this, and I apologize if stuff was out of focus. Not exactly a videographer, so if someone can use information here or gives you some ideas, you know what, I would like to say it is sturdy, but I think if I were to do it again, I would probably go with steel or thicker aluminum. I don't know if going to 70-75 aluminum would do anything for it. I mean, sure, it's more sturdy. It's it's a lot stronger, but for the more strength that you get with that and the price that comes along with it, I really don't know if it would justify the cost there. I really think I would go with steel. So if I realize that this isn't cutting it for me, I could always put a plate on the table. I was thinking of that anyway, just to keep it from getting all dinged up and stuff. So I did run an indicator across the table before the vise was on it, and it didn't move. It was a stare at last word. If I remember right, it was this back corner here, about 4 inches from the end. The indicator dropped down almost a thousandth, maybe 8/10, 7/10, something like that. And I didn't really get too concerned with that because I figured it's probably just a variance in the surface there. Like I say, the 8 bearing blocks keep it nice and flat, and for what I do, it's pretty good. I mean, it's a lot better than what was on the table before, on the mill before. I mean, if you say you took a fly cutter and fly cut a long piece, maybe a foot, 2 feet long, flipped it over, took another cut, you would probably wind up with close to a 20 thousandths belly in the part. The two ends would be small and the middle would be big, because obviously the middle is sagging through the worn spot or the sweet spot where everyone ran the parts, and that's how you get those bows and bellies in your parts. So I will say this for the guy that sold me this: it was an absolute Rembrandt with the paint job. Really nice work. But as far as doing any real work to the machine, I did a lot to get it going to where it is now. I mean, just by the nameplate or the speeds, you can see that's pretty well worn. A lot of hands resting up there. It's seen a lot of service. But I'll fire it up real quick. You can hear it. Granted that's only 560, but it's not bad. It serves my purposes for now. And you know, we'll see what's next. Like I say, I did want to do the Z, put a servo motor on that, and I'm not really sure which way I'm going to go about it. Either mount it to the shaft here, or over here, or yeah, I don't really like that idea too much because you're working off of a gear inside. I'd rather just put like a ball screw in, and that way, you know, you pretty much going to eliminate any backlash or play in the system. I think that's the way I'm going to go with it. So anyway, thanks for watching, and I hope it was some help to some people. And if you do like what you saw, please subscribe, tell a friend, and until next time, be safe on the machines. Take care. Bye bye.